Hello everyone, my name is KAJAL BHATIA. I'm an accredited nutritionist, founder of a licensed plant-based academy and research center KBH. I've also founded PlantPa, a 100% plant-based balanced nutrition support brand. Post my academic studies, I was grateful to be introduced to the magic of plant-based diets and since have worked exclusively in the sphere of plant-based nutrition over 20 years. Today's topic, protein, is one of the three that is particularly requested by all in my many consults, sessions, even the foods we create, etc. It's bizarre how it still holds pole position, just like the name Proteus, almost as if there's no other ingredient or nutrient in foods. It is sometimes a pain point to share protein in an isolated concept, whether rationalizing with colleagues, clients, or sharing as an educator, especially when one is working within the entire realm of whole food plant-based nutrition, where no nutrient can be truly isolated. This does take me back to my internship days at Fortis and Science Hospital, where there was meticulous planning for many, especially when it became a matter of survival. Later, my experience with corporate consulting at BCG, Google, and Raw Pressery with a larger collective pool enabled me to have a more realistic view and research on the impact of these plans. That was also when I was actually goaded into creating products for support both at home and at work. I myself started questioning at the time, why is everyone only into protein bars and nutrition, especially, and why not energy and balance with more carbohydrates and minerals and stuff like that? So, for many, still the naysayers and the ardent believers, this is what protein is, and I'm going to try my best. So what is protein for us? Proteins are very large molecules which are composed of basic units called amino acids. These proteins contain carbon, hydrogen, oxygen, nitrogen, and sulfur. Nitrogen being the key element because that is exactly the same constituent that is there in plants. Proteins were discovered by Berzelius in 1838 from the Greek word protease. It's interesting to know that protein is not only species specific but also organ specific. For instance, the protein of a human and that of a horse, or the requirements of it would be largely different. And similarly, in a human, the protein of a muscle would be different from the protein of a liver or a brain. So people not familiar with vegan nutrition often assume that it's terribly hard to get enough protein on a vegan diet. And that is if they think there is any protein in plant-based foods at all. On the other hand, once educated, many vegans have the opposite view, considering protein a myth. The truth lies somewhere in the middle. So when we wonder how come we focus on plants also giving us protein, one needs to see the structure of the plant. Plants do have them as a part of the macronutrient structure too. In fact, just like carbon, hydrogen, and oxygen, and nitrogen, which exists in human protein. Nitrogen is a very important nutrient even for the plants. It's also the primary building block for plant protoplasm and hence the life in plants. What does the bacteria do? The bacteria in the soil actually converts the atmospheric nitrogen into ammonia so that the plants can synthesize this and make its building block for growth. So let's talk about the functions of protein. Most of this is as per academia. However, Jack Norris, a protein researcher today, even asserts protein is important for maintaining muscle and bone mass, for keeping the immune system strong and preventing fatigue. Amongst the many functions, cell building is an important one as protein contains the amino acid, the building block that our body uses to build and maintain muscles, bone, skin, blood, and other organs. Protein is a significant energy source as each gram of protein gives you 4 kilocalories, just like carbohydrate. But the distinguishing factor here, and it's easy to notice, that only when fat and the carbohydrate reserves are used up by the body, then it turns to protein as an additional source of energy. That is also where something like muscle wasting is starting to occur. So one needs to be careful of that. Enzymes. All enzymes are proteinic in nature. Protein especially is a regulator of water balance. It also is a biological buffer, especially when it comes to accepting or donating hydrogen ions. Protein is a beautiful carrier especially in the form of transport protein that serves the function of moving other materials within an organism. One cannot deny the significant function of blood protein in the form of hemoglobin. And importantly, protein forms the structural element and the structural unit for most of our body parts. Example, the liver cell membrane contains 50 to 60% protein. Muscle contains 20% protein, and keratin is the protein which forms hair, nail, etc. Protein also functions as a lubricant which surrounds the joints. It is present as mucus in the respiratory, oral cavity, vaginal tract, and even the rectal cavity, thereby reducing the irritation which might be caused by materials moving through these passages. Protein, also importantly and much discussed in this pandemic, also is significant for the immune function, especially when it comes to the T and the B cells, which are those fighter cells that protect the body against foreign cells. And last but not the least, protein is been known to be a macronutrient that is important for satiety. That means that if you eat proteins, you will feel fuller for longer and you're likely to naturally eat less without even trying. Now, in my experience and with many of my patients, we have actually seen that yes, protein helps you feel full, but at the same time, the craving for carbohydrate also shows up. And that's where food combining becomes very important for satiety. I will move on to types of protein, especially complete, partially complete, and incomplete proteins. The base of this is that there are some proteins that are good for maintaining life and also for growth, whereas there are some proteins like the partially complete and the incomplete proteins which are incapable of maintaining life and or also of supporting growth. Some for example, are glycinin in soybean, which is a complete protein. The partially incomplete protein is gliadin of wheat. And as per research, the total incomplete protein that is not at all needed by the body is iron. And here again, food combining takes prime importance. Well, just ingesting protein and thinking that that's going to give us energy, strength, be a part of our enzymes, protein carriers, etc. is not enough. It is important to know that protein breaks down into various types of amino acids so that it can use that as a building block for growth. There are essential and non-essential amino acids, and I'm not going to talk about non-essential amino acids simply because they are being synthesized in the body. The essential amino acids cannot be synthesized by the body and they are needed through the diet. There are three especially amongst these, which is often known as the branch chain amino acids, which is leucine, isoleucine, and valine. Leucine being the most significant because it helps in muscle synthesis, especially for active and even older adults. We have seen, especially in my earlier years at university, that there was a lot of research coming out in terms of food combining of two or more or multiple amino acids when creating a meal. For example, the popular khichdi, simply because the pulses were lacking in methionine and the cereals were lacking in lysine. So let's combine the two and give a complete meal. However, today that no longer holds true. What holds true even better is that there is a 24-hour amino acid pool that the body uses to be able to synthesize what kind of amino acid or what kind of protein is required to be able to build. And if one eats a good quality protein and a balanced meal, then that is definitely possible. But to even determine that how much protein should one have, of course, this is a never-ending question. So to understand RDA, it is important to understand protein digestion. Proteins are colloids and amino acids are crystalloids. Each plant and animal first breaks down the protein into crystalloids to build its own colloids. Protein has to be ingested in food form and it needs to be broken down. There's no getting away from that. But any protein, even in excess is also an issue, especially when it comes to extreme supplementation. Direct inclusion of amino acids such as leucine, which is very popular amongst a certain audience, are not advised. Please thoroughly check with your gym trainer, nutritionist, or doctor if taking so. As far as the amino acids profile and the recommended dietary allowance is concerned, it is important to know how it is brought into being. Simply the fact that dietary protein is broken down into amino acids, where it further is deaminated, and there is amino nitrogen, which is broken down further into urea, and also used for biosynthesis of other amino acids. This amino acid, which is going in the form of urea, or is excreted either through the urine, your feces, your sweat, etc. The measure of that is something that was taken over time through your urine test to be able to see as an RDA that is used for replenishment of your protein. So interestingly, when one is assessing biological value, one is trying to understand the nutrient quality of absorption of that particular food. However, it is seen that most of it is in a raw state when it's assessed for biological value. Now, animals and raw-tarians eat raw, so metrics of the same where protein is easily absorbed is high. But for humans, where both animal and plant foods are largely cooked, the biological value of either is challenging to assess independently. On the left is the compact natural protein with 4-layer structure, which is the primary, secondary, tertiary, and quaternary, ready to do its job, both in form of structure and function. But what you see on the right at 65 degrees is protein that is completely denatured, and this protein becomes like a long chain amino acid, losing structure, hence also impacting function in some form. There is data luckily sharing that this does not impact. However, there is a nuance here to understand that it is also important to understand the need for more raw in food plans. Does protein requirement at various stages differ? Yes, of course it does. It is interesting to see that at the initial stage of a human life, when there is a buildup in significant growth, just 100 gram of human milk, which contains 1 gram of protein, is just enough to be able to sustain that. Hopefully, the breastfeeding period is much longer. However, that is something that has always been significant to understand as data. But there is various stages at life where protein requirement does go up, especially when it comes to critical care, burns patients during AIDS, as a situation, even a hypothyroidism where there is intense muscle wasting. Of course, it's important to also know that this, along with protein, along with exercise in some form, does help build strength and also bring the muscle function back to the body. Cancer, there are both ways studies that have come up where a high protein or a low protein diet helps, especially when it comes to high protein, even if it is a natural plant-based diet. With some top up, there has been seen a significant improvement in cancer healing, and especially because it is an inflammatory stage. There is overweight and obese patients, which definitely, when the carbohydrate quality itself is changed for a better quality, or the protein is introduced at various stages, that does help in reduction of the calories or the weight, as one knows. Visceral fat, now this, and low lean body mass, both are significant as far as having more protein in the plan will ensure a lesser visceral fat and a better lean body mass. Yeah, of course, this again significantly built with exercise does show the change, but not on its own. There has to be exercise involved. And in fact, for all these stages, pregnant women and lactating women, it is known to be talked about that for the current RDA, there is minimum of 60 grams of protein a day which will account for approximately 20 to 25% of one's calorie intake when one is pregnant. And as far as lactating is concerned, at least 1.5 gram protein per kg per day, different to the normal RDA of 0.8. It's important to note that for pregnant and lactating, one doesn't need to have double the protein just because they are bearing or conceiving a child. It is just simply fine to be having sufficient protein that ranges from 0.8 to 1.6, depending on the age and the range, and of course the goal. Um, Moving on to the different kind of diets that have come across in our history based around protein, right? Of course, there is the low, moderate, and high protein animal based diet that have gone on for decades, and now significantly so the low, moderate, and high protein plant based diet that are coming for various people at various stages. In these plant based diets, when it comes to many, many choose to keep it at 0.8, some choose to keep it at 1.2, 1.6, etc., depending on the stage and the activity that one is experiencing. However, it's more important for me to talk about the high protein, high fat diet, which is also a matter of discussion, and it is abundant in society as we speak today. It is the keto diet, or the earlier modulated Atkins diet. Basically, a ketogenic diet is the most extreme form of low carbohydrate. And it is an eating plan that is also very, not only low in carbohydrate, but also very high in fat. It was intentionally, actually, originally known to be treating for the use of diabetes and epilepsy, but still maintains a significant role in the treatment of severe treatment resistant epilepsy, where there is high rates of seizure control. The basic premise is that if the body does not have access to glucose, glycogen stores will be used up and the body will be turning to an alternate fuel called ketones, which then will give the body its energy needs. It is a very popular approach currently for weight loss. However, uh, it is also known to have long-term effects where there is a lot of inflammation, a lot of fat circulation in the body. It has also been fatal for many, and there is no significant data that this is actually a sustainable plan and a way of life that one can carry on going forward. Yes, it does bring down diabetes. Yes, it does reduce your weight. Yes, it helps in epilepsy, but especially as far as weight control and glucose management is concerned, a short-term measure is all that it shows. Long-term, the efficacy of it is still to be tested. So significantly, the plant-based diets are far more, sustainable and beneficial, whether it is uh, low protein, moderate protein, or high protein. Coming uh, Coming to why animal versus plant protein, it is important to see that uh, there are many factors that weigh much superiorly to for plant protein over animal. That is better digestion and recovery, where a person ingesting animal protein often faces indigestion. The even the legumes and the pulse contain more sulfur in animal protein, thus leading to a significant acid release, which actually is known to also release calcium from the body, and thus leading to osteopenia, osteoporotic situations. Of course, plant-based diets are high in antioxidants, much higher than animal protein. The animal protein and plant protein both are rich in saturated and unsaturated fat, but it is important to share here that plant-based diets have the protective mechanism of the fiber that is there in these plants, which are helping, even if it's saturated fat, help these fats be released, the excess fats be released from the blood. There is a positive effect overall on of the plant-based diets on the system, simply because they are non-inflammatory and they have zero cholesterol. And so here, when we come to the food groups that are essentially then animal and plant nutrition. In animal-based groups, of course, there's the fruits, nuts, grains, legumes, dairy products, eggs, and all kinds of meats, which is being followed in various exchanges for um, uh, different kind of diets and etc. Whereas the plant-based groups, the protein, the food groups that are rich in protein are also available, which is the fruits which have olives and avocados, which are rich in protein. There's all nuts have better protein except for chestnuts, coconuts, and acorns. There are grains, quinoa, amaranth, buckwheat, brown rice, couscous, oats, all richer in protein. There's legumes, which is soy, starting from soy all the way to peanuts, various quality of it, but all accessible and convenient today. And vegetables. I do want to mention vegetables. I have obviously not talking about dairy, eggs, and any kind of lean meat in the plant-based diets due to the issues related to it above. But as far as vegetables is concerned, I particularly, even though they are low in protein, I have clubbed it with the plant-based groups that are rich in protein, because it's important to have that element of food combining where the minerals that are there, in spite of being low protein, support the plant with the protein itself that it contains to be able to give better results and impact on the body. So the macronutrient and the micronutrient do come in place together. Uh, and simply moving on to the food plants, there's enough protein, as you can see, in both of these lifestyle plans, when it's sedentary or active lifestyle and weight balance. One has to simply tweak the exchange group to be able to give better health to the individual. Example, in the sedentary lifestyle, one just needs to move from wheat away to amaranth, have sprouts added to veggie, etc. Top up happens in more natural and added form in active lifestyle plans, by even adding more plant-based foods like tofu, protein concentrates, whether it's in the form of peanut powder or almond powder, even isolates when active. At the same time, one cannot look at just protein anymore in isolation. It needs to be better tied into the entire food combining element with various other macro and micronutrients. The long-term data does not support any individual isolated diet plan as a healthy option. Going up to 0.8 or 1 or 1.2 or 1.4 per kg body weight is good for plant-based protein, and one can account for some lack of absorption and amino acid variance in profile. But then we must look to clinical outcomes for plant-based versus animal protein, especially as a nutritionist and as a clinical educator. I would like to look at all-cause mortality. Is that something that is increasing with animal diets or with plant-based diets? What about cancer, CVD, diabetes, even muscle mass, for instance, when it comes to older people and wanting to reduce the risk of sarcopenia? I do care about the clinical outcomes, and so it is important that if people feel that they are not getting enough protein in their plants, which is important, then one can optimize in many different ways. But just as there are lack of good quality nitrogen studies on plant versus animal proteins in human, there is no evidence that just getting 1 kg plant-based protein is any worse off than animal protein. And especially taking into considerations the newer studies looking at healthy plant-based interests index, our job is actually to promote health and not necessarily only nitrogen balance. And so one needs to look at the entire uh, uh, ecosystem of the macronutrient and micronutrient together today, including proteins, which is an important constituent. I thank all these amazing contributors to the work that was done, and the research that was put together, and a lot of it has also come from this up to now. So thanking you for watching this, and I wish you the best of health forever.